The vast majority of people who've lost a limb can still feel it, not as a memory or vague shape, but in complete, lifelike detail. They can flex their phantom fingers and sometimes even feel the chafe of a watch band or the throb of an ingrown toenail. And astonishingly enough, occasionally, even people born without a limb can feel a phantom. So what causes phantom limb sensations? The accuracy of these apparitions suggests that we have a map of the body in our brains, and the fact that it's possible for someone who's never had a limb to feel one implies we are born with at least the beginnings of this map. But one thing sets the phantoms that appear after amputation apart from their flesh and blood predecessors. The vast majority of them are painful. To fully understand phantom limbs and phantom pain, we have to consider the entire pathway, from limb to brain. Our limbs are full of sensory neurons responsible for everything from the textures we feel with our fingertips to our understanding of where our bodies are in space. Neural pathways carry this sensory input through the spinal cord and up to the brain. Since so much of this path lies outside the limb itself, most of it remains behind after an amputation. But the loss of a limb alters the way signals travel at every step of the pathway. At the site of an amputation, severed nerve endings can thicken and become more sensitive, transmitting distress signals even in response to mild pressure. Under normal circumstances, these signals would be curtailed in the dorsal horn of the spinal cord. For reasons we don't fully understand, after an amputation, there is a loss of this inhibitory control in the dorsal horn, and signals can intensify. Once they pass through the spinal cord, sensory signals reach the brain. There, the somatosensory cortex processes them. The entire body is mapped in this cortex. Sensitive body parts with many nerve endings, like the lips and hands, are represented by the largest areas. The cortical homunculus is a model of the human body with proportions based on the size of each body part's representation in the cortex. The amount of cortex devoted to a specific body part can grow or shrink based on how much sensory input the brain receives from that body part. For example, representation of the left hand is larger in violinists than in non-violinists. The brain also increases cortical representation when a body part is injured in order to heighten sensations that alert us to danger. This increased representation can lead to phantom pain. The cortical map is also most likely responsible for the feeling of body parts that are no longer there because they still have representation in the brain. Over time, this representation may shrink, and the phantom limb may shrink with it. But phantom limb sensations don't necessarily disappear on their own. Treatment for phantom pain usually requires a combination of physical therapy, medications for pain management, prosthetics, and time.